Okay, we're going to be looking at solving using logarithms today to solve exponential equations. Okay. All right, so let's get started. So again, you could look at your calculator on how to put in numbers for x and do trial and error to figure out which one would equal 8, especially since we have a multiple choice scenario here. But we could also do this algebraically. Okay, so let's first look in our calculator. So we can just do good old trial and error. We can just type in our answer choices and see which one's going to give us the 8. Oh, and it was the first one. So 1/4. Now, if we want to do this algebraically, it's going to look a little different, obviously. So let's look at that. Algebraically, so what we can do here is we can make sure that the bases are the same. So if you'll notice, 16 can be written as 2 to the 4th, and 8 can be written as 2 to the 3rd. And remember our exponent rules that if you raise a power to a power, your multiplication. So we have 2 to the 12x equals 2 to the 3rd. And since the bases are the same, we can set our exponents equal to each other. So 12x equals 3, divide by 12, and reduce, and we get 1/4. All right, let's try one. Let's do one algebraically because right now we don't have any answer choices. So the first thing that we're going to do is try to get these to be in the same base. So 27 and 81. We need to write those so that they have the same base. So 27 can be written as 3 cubed. And 81 can be written as, so 81 can be written as 3 to the 4th. And I kind of use my calculator to do a little trial and error. All right, and so now our bases are the same, so we take our exponents and we set them equal to each other. So 3 times 3x is 9x equals 4. So x would be 4/9, and we can reduce, I think, no, we cannot reduce. If we can, then we should. Okay, so 4/9. And then again, you could check this in your calculator. Put 4/9 in place of the x and see if indeed they equal each other. Okay? All right, let's try this one. 15 raised to 3x equals 285. So we're going to write the original equation. And we're going to take the logarithm base 10 of both sides. All right, now, before we get to this, the base 10, you'll notice that I didn't write a 10 here. If there is no base written there, it's understood to be a base of 10, okay? So if I take as long as I do the same thing to both sides, I'm keeping my equation balanced. So if I want to isolate the x, we have a property that says, a rule, that if we have log of a to the x equals x log of a, this exponent's going to get kicked out front. It's called the power rule. So we're going to write that and move that 3x way out front. Divide both sides. So now we just have x left over. And we can actually use our calculator to do log base of 10. So let me show you that piece of it. All right, so here we are at the calculator. And you'll notice there's a log button if you have a graphic calculator over here on the left-hand side. Notice right above it, see where it says 10 to the x power? That kind of helps you realize that that is the log that has a base of 10. And you can see the base of 10 written as the exponential. Okay, so if we were to type in log of base 10 of 285 And again, we don't have to write the 10 because it's understood to be there. It's called the common logarithm. Divided by, I'm going to put parentheses here, 3 log base 10 is understood to be there again, of 15. Oops. All right, and so it'll give us a decimal. If we want a fractional part of it, you could hit the math key and then choose number 1. Oh, it's not going to give me a fraction after all. I thought it would. Okay. All right, so 0.6958. All right, so again, if you wanted to check your answer, you could put this number back in for the x in your original equation and see if it works out. See if they're equal, and as a way of checking your answer. And there, now remember we did round this answer, so it's going to be pretty close. Okay. Another way to solve these type of problems is you can solve these graphically. We've done a little bit of that before, where you put the left-hand side in your calculator in the y equals screen, and you put the right-hand side in y sub 2. And then you look for the intersection point. Okay. So, or again, you could do this algebraically. Method 2, they say that you can also use your table. I personally like the graph a little bit better because I can actually see it and get a visual representation. Okay, so let me model this little process here for you. So again, you would type in the left-hand side and then the right-hand side of the equation. Now, the only downfall with this particular method is that this number 6,000 is like really, really big. And so you're going to have to change your window when you hit graph in order to see the intersection point. And you may or may not, you may have to fool around with that window several times because as you see here, it's a little hard to tell where these are going to intersect. So if we look at the window, and remember we said y was 6,000. So y maximum is going to have to be something a little bit bigger than that on my window. If I put in like 7,000. And I'm going to count by 1,000 on my y-axis. And I'm going to hit the graph and see if that helps me at all. Okay, so there, I can see the intersection point now. And so for the calculator to give you that intersection, you're going to hit the second and then the trace key. And we want intersection, so choose number 5. And we're going to hit enter a few times. First curve, second curve. It does a really lousy guess. And then here's our intersection. When x is right around 2.1, our y coordinate is 6,000. Again, we're going to have to round that off a little bit. Okay, we're going to ask to solve this equation. And notice that the base is not written, so it's understood to be a 10 here. It's a common logarithm. So we're going to do that water cycle idea. So 10 squared is going to equal 4x minus 3. And we'll solve for x. So 10 squared is 100. Add 3. So x is 103 divided by 4, and that's going to give us a decimal equivalency in your calculator. So 25, oh, it actually comes out nice and terminating decimal. 25.75.